Students, Miss Tom here. You ready to see some awesome magic? Ready? One, two, three. I throw it, then I catch it. I throw it, and then I catch it. Now, how did I do that? Wouldn't it be awesome if magic was real? Well, sorry, it isn't. Well, according to science. Sorry, Harry Potter. It's okay, Miss Tom. I'm just a fictional character, and fictional characters aren't real. So, yes, sorry, students. Magic is not real. And I'm actually going to show you by revealing my magic trick. Now, with magic, it's all about illusion, preparation, and what's hidden to the human eye. So I had to do this video several times to make sure everything worked accordingly. So all my trick is literally taping a toothpick to my thumb and then making sure it's in a way that when I open up my hand, the toothpick isn't revealed. So many times when I did the video, a lot of the takes had the toothpick showing, so I had to be very careful about that. So you're holding it like this. You don't know that it's taped to my thumb. I'm making sure to hold it specifically. I made sure you all saw the front side of me, because if you saw the back of my hand, the trick would have been revealed. And when I opened it, I made sure it was at an angle where the toothpick was still concealed. So there you go. Cat's out of the bag. Sorry. There's no such thing as magic because of science, and specifically because of the topic we're learning today, which is the law of conservation of matter, which simply states that nothing can just vanish in front of your eyes or disappear. And we'll be exploring that lesson and that law more today, and I hope you learn a lot and have a lot of fun.
I hope you enjoyed that awesome magic video and you are able to test it out at home. Let's get started on examining our objective slash learning target. By the end of class today or the end of this video, you should be able to explain the law of conservation of matter and energy and apply it toward various chemical equations. So be looking at chemical equations to see if it actually follows this law. And of course, you're going to show me this by completing the practice sheet, specifically the practice questions. The practice questions we'll be focusing on for you to show me that you understand what you're learning today are these practice questions right here. And if we go to the homework, whatever you do not finish in class is what you'll be finishing at home. Therefore, if you do not finish all of these practice questions, you will be again finishing at home. And you can see that there are several components to it. And you know that if you have a question, your answers must restate the most important parts of the question in a complete sentence. I don't want to see any it's or because that is an incomplete sentence. So if the question is, does the chemical equation represent the law of conservation of matter? Your answer should start with, the chemical equation does represent the law of conservation of matter because blah 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 blah. Not yes, it is supporting. You need to state the entire and most important parts of the question. Let's get started. As you saw in the video, unfortunately, magic just doesn't exist. It's not real. There's no such thing as magic, as quoted from the very first Harry Potter movie, and that's because of this law. And the law of conservation of matter simply states that matter can be neither created nor destroyed, meaning we can't make it appear out of nothing and then make it vanish into nothing. It had to have existed in our universe in some way, shape, or form. We can't just make things appear and just make them disappear and never have any presence. Now, if we look and we break up this concept, you see the key word in here is law. And if you think of law, you probably remember dun, 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 the Law and Order, Special Vixen Units, all these other spin-offs. And we know that when it comes to law, it's all about who enforces the law. So in this case, we have police officers that ensure that the citizens are obeying the law and following it. And if they don't, then there's consequences. So the law of conservation of matter kind of follows a similar philosophy in a sense. But in this case, this law is not enforced by police officers. It's actually enforced by nature itself and the laws of chemistry and physics and science and the universe in general. Conservation is actually to preserve and carefully utilize natural resources in order to prevent its depletion. So when we're talking about the law of conservation of matter and things being converted from one form to another, some things are lost in the process. And so conservation in this case is how can we preserve some of the items, the reactants that are rearranged to create a product in this process. The law of conservation of matter also applies to energy. And we know that energy, just like matter, is neither created nor destroyed. So it just is rearranged and changed in some way. We know that you gain your energy from glucose and by consuming food products like this yummy looking In-N-Out. It makes me really hungry just looking at that picture. We know we consume this glucose, it goes into our body, and then this chemical energy is converted into energy that we can use, that makes us go up this hill, and then the hill can absorb the energy in addition to the bike, and then the energy is released somehow. So it's not that the food energy or chemical energy that we ate just disappeared, it actually became converted and used and then just dissipated. So just like matter, energy can't also be created nor destroyed. Now, if we apply the law of conservation, again, nothing can be just created out of nothing and then disappeared and destroyed. It can also be seen as specifically in this case of chemical reactions. And it's all about how these atoms are rearranged to form a new combination of a product. And according to the law of conservation of matter, in chemical reactions, the mass of the reactant, so what you start off with, always must equal the mass of the product. So if you start off with something, you end up with something exactly the same. Example is these pictures. You could see that there are, we use these colored circles to represent different types of atoms. So we started off with 3 red atoms in our reactant side. And you can see that we ended also with 3 reactants of 3 of the red circles in the product side. So either way, we know that it started with 3, so it ends with 3, which supports the law of conservation of matter. And according to science, this is true. So if you start with 3, you have to end with 3. You don't end with 2 and just lose one of them for some reason. You don't end with 4. And this is helpful, especially as a chemist, when you're trying to develop formulas and then seeing how and what would occur when it becomes a reactant. We could see that when you start off with the reactants, it's different than what you get in the product side. However, the number of atoms are still the same for each. You start off with 3 red, you end with 3 red. You start with 2 yellow, you end with 2 yellow. You start off with 1, 2, 3, 4, 5 blue circles, you end up with 4 blue circles, and so on and so forth. So reactants and products are always equal. And again, as you stated, it's the same thing applies with chemical formulas. So if you start off with 2 copper atoms, your end product, it has to have 2 copper atoms. If you start in the reactant side with 2 oxygen atoms, you will end up with 2 oxygen atoms. And I noticed that I just made a smiley face here. In general, you can see that when you are going through a chemical reaction, it's all about changing and rearranging the atoms you started with to make a brand new product. But of course, the amounts of atoms used are exactly the same and equal to support the law of conservation of matter. Now let's review. The law of conservation of matter states that matter can be neither blank nor blank. What are the blanks? I'll give you a few seconds to think about that. You can say it out loud in your head. Okay, and we know that the law of conservation of matter states that matter can be neither created nor destroyed. So we can't make something appear out of nothing and just vanish. It has to have already existed, or it kind of changed into something else, which made it kind of look like it got destroyed, but it's still there. You just can't eliminate it from the world. It's not possible. And according to the law of conservation of matter, no new atoms are created and no new atoms are destroyed. So again, if you start off with 3 black circles and 3, which represent atoms of course, and 3 white circles, you're going to end up with the same number. We don't have any new black circles appearing. We don't have any black circles disappearing. What you start with is what you end with. Think of it like making a cake, right? If you started off with 2 eggs, you don't end up with 3 eggs in your cake, or 1 egg. You start off with 2, so your end product will have 2 to make as well. And let's do another check-in. So according to the law of conservation of matter, the mass of the reactants, meaning this side right here, is blank to the mass of the reactant or products on this side. Got the answer? Okay, so we know, and simply this picture states it, that according to the law of conservation of mass, the mass or matter, the mass of the reactants must equal the mass of the product. So again, if we start off with 2 copper atoms, then we're going to end up in our product side with 2 copper atoms. If our reactant sides have 2 oxygen atoms, we're going to end up with 2 oxygen atoms. So in general, the mass of the reactants and the products are always equal. Okay, now we are ready to do the example and the practice question. So I'm going to do one together, and then I'll let you pause the video and you can work on them yourself, and then you can see your answers. Okay, so we are going to break this down to products and reactant side. So we have the reactant side over here. I'm going to make that red. We're going to do it step by step. So identify the element and the number of atoms. So I have oxygen here, and there's 2 oxygen, and I have hydrogen here, and we know that the subscript multiplies itself with the coefficient, and so we have 4 hydrogen here, and that's our reactant side. Let me change color really quickly. Can I change color? Let's see. Sorry. Oh, there you go. Ink color. If we go to the product side, I'm going to just write the same colors or order here. So we know that the coefficient applies itself to the coefficient over, or the subscript right here, and we know if there's no subscript, then it's 1. So 2 times 1 is 2, so there's 2 oxygen atoms here, and we know that there are 4 hydrogen atoms here because they multiply over there. Sorry if it's a little difficult to see. And now we look at the 2. Is it balanced? Are the atoms the same? And we can see that oxygen, we start off with 2 oxygen atoms, and then we end up with 2 oxygen atoms. So that means that they're balanced on this side. We started off with 4 hydrogen atoms, and then we ended with 4 hydrogen atoms, so it's balanced here. So in this case, this chemical equation is balanced. So we're balanced. Oops, spelled balance wrong. There's A right there. And now we explain in a complete sentence. And in this case, to save time, I kind of pre-typed it, but remember for you all, you'll be writing it. So yes, the chemical equation does represent the law of conservation of matter because the mass of the reactants are the same. I'm sorry if my handwriting is a little difficult. It's kind of tricky to write with your finger on a screen. The same as the mass of the product. Let's continue to the next one. And if you're ready to go, then you can actually get started right away by yourself, and you can pause this video and then start it up again when you are ready to continue. Okay, so we're going to do this one. I'm just going to get started and do the blue. Okay, and identifying the products first because I have the blue already. And so we see sodium, there's only 1. Chlorine, there are 3. If I go to the Reactant side here, we can see that there's 2 for sodium. Chlorine, there's only 1, and now we can see the discrepancy. We can see that it is not balanced here. It starts with 2, it ends with 1. What happened to that other sodium atom? And then for some reason, chlorine also gained some. So in this case, it is unbalanced, and we know that it does not support the law of conservation of matter because of that. And this unbalance and ending and starting with different numbers of atoms does not support the law of conservation of matter. Let's do the next one. So the next one, I'm going to start with aluminum is 1, I believe that's nickel is 3, and bromine is also 3. And, oops, sorry. And let me see over here, we have the aluminum is 1, nickel is 3, bromine is 3. And we're all happy because they are all exactly the same, which means they are balanced. Now we reach the introduction to our final project, which you can start beginning today and will be due by next week. It's involving you creating a stop motion animation that describes and provides examples of the law of conservation of matter, and you will be using the very exciting Lego Movie app that is available via your iPad. If you didn't know, there's actually many movies that are created through stop motion animation, and 2 of them being one of my favorites, Nightmare Before Christmas and Coraline. With stop motion animation, it takes a lot of, it's very tedious and detailed. You have to move a figure and then take a picture, move a figure, take a picture, move it, take a picture, and so on and so forth. And then when you put them all together, then you have this awesome, amazing like footage of something moving. It does require a lot of planning. You could see in this background picture that for The Nightmare Before Christmas, which took about 6 years to produce, they had the storyboard and show what happens in each frame and then make it appear in actual real life. And so you'll be doing that. And many Lego movies, if you didn't know, were also created through stop motion animation, with the exception of the most recent Lego movie, the actual Lego movie, which was created through CG, and which is pretty amazing because they actually look and they have that feel of the Legos when they're in action. When you use the Lego Movie app, it's pretty self-explanatory. You'll be using that to take pictures. It's more easy, or it's easier than using your camera. And then you'll be putting it into iMovie if needed for more special effects and more sounds. I'm going to show you some examples to give you some ideas and hopefully get those creative juices flowing. This is the first one that was produced by Andrea. She was in my 5th period class last year, and she did an amazing job, and hers is very unique compared to many of the others, so enjoy. And you can see that Andreas is pretty unique. She incorporates some of the stop motion in the sense of moving characters and figures to show that they're moving. And then she also used stop motion animation to do writing. So that's another way that you can go about doing your project. I'm going to show you another more Lego Movie creation with Lydia, and hers is hilarious because I loved how she animated her voice for the different characters. Enjoy! Fendray, as you can see that hers is hilarious because she has music, the applause. She also has the stop motion occurring. I'm going to continue to play. And she incorporated many other sounds, and she also incorporated other visual pictures as well. I'm going to show you one final one, which is by Marcus, and he used Lego, or not Lego figurines, but he used action figurines, and I loved how he animated the explosion, so you can watch and see.
Hey there, I think there's a helicopter coming. Oh no, it's gonna crash! Ah! Well, actually, it's still there according to law of conservation of matter. What do you mean? The law of conservation.
And in many of the projects, you can see that they incorporate some dialogue, so someone asking questions, someone providing answer. Well, I hope those 3 projects inspired you to create your own innovative way of explaining the law of conservation of matter or energy, and I look forward to seeing your products. And make sure that you email me through Canvas or message me through Class Dojo if you have any questions.